guys, here's a function. Our job is to find the local extrema of it, and I'm going to walk you through the problem. Okay, so if f of x is our function and it equals x plus 1 over x, we first want to find the derivative of that. I'll tell you why in a second. So f of x, but the derivative of f of x equals 1, which is the derivative of x, plus, and you can rewrite this as x to the negative 1 exponent. And so if you want to take the derivative of that, you minus 1 from the exponent, so it's negative 2. All right? And this can also be written as 1 over x squared. And because we are multiplying the negative 1 out to the top, or to the coefficient, that turns to negative 2. Because negative 1 times x is negative x. So you get negative x to the negative second power. All right? And because this is our derivative, or slope, we want to find the area. We want to find, this is a graph. Here's our function, whatever. We want to find where the slope, which is the derivative, this function, is changing from positive to negative. It's like this. The slope is changing like right here, or like this, from negative to positive. These points right here are our maxes and mins. All right? So to find where our slope is changing, we need to find where the slope is 0. All right? Because it has to change from 0 first to change from positive to negative, or vice versa. So we set this whole function equals 1 minus 1 over x squared equals 0. Simplify that, x squared equals 1. Apply x squared, and then I'll take the square root, so you get plus or negative 1 equals x. These are our critical points. So that means on this function, this original function, these are the points, positive and negative 1, where the slope is 0. So that means these points are our maxes or our mins. So how do we test that? We make a number line and label these on it. Negative 1. And another note, this also, x cannot equal 0 in this function as well, because 1 over 0 would be an indeterminate form. We can't have that. So come down here, make an adjustment. X cannot equal 0. Right? Okay. So to test these functions, or to test these intervals, we need to plug in values that are either lower than negative 1, between 1 and negative 1, or larger than negative 1 to see what the sign of the slope is, like if it's positive or negative, because we want to see where it changes and what it changes to. All right? So we can pick any arbitrary number less than negative 1, go with negative 2, 1 over negative 2, let's write it over here. 1 minus 1 over 2 squared equals 0. 1/4, and that's going to give us positive 3/4. So that means any slope where the x is less than negative 1 is going to be positive. We can do the same thing over here. F of 2, or the derivative of f of 2, equals 1 minus 1 over 2 squared. It's going to give us a positive number as well. So that means anything bigger than 1 is going to be positive. And then we can test a value here. We cannot test 0 because x can equal 0, as we saw down here. So I guess we'll pick, so 1/2 equals 1 minus 1 over 1/2 squared. All right, it equals 1 over 4th, and that's going to give us 1 minus 4, and that's going to give us a negative value, negative 3. So that means that any x value lower than or less than negative 1, slope is going to be positive. Any x value, any point at the function where x is larger than plus 1, the slope is going to be positive. And at any x value between these two, but in this interval between negative 1 and 1, the slope is going to be negative. And so over here, because it's changing, the slope is changing from positive to negative, that means we have a max right here. Local max. Over here, because it's changing from negative to positive, at positive 1 means at positive 1, a local min. All right? And so to find the actual points, we just plug in these values into our function. So f at negative 1, which is our max, equals x plus 1 over negative 1. Oops, should be negative 1. So f negative 1 equals 1 minus 1, or negative 1 minus 1 is negative 2. So our min, local min, excuse me, local min is at negative 1, negative 2. And then to test for our max, we plug in our, oh wait, sorry, this should be local max. To test for our min, plug in negative 1 into our original function. We get 1 plus 1 over 1 equal 2. So local min is at 1 comma 2. And that's how you find the local mins and maxes to any given function.